Hi everyone, welcome back to the channel. I'm Hussein Younes. If you're new to the channel, why you should even listen to me. So I'm an AI engineer and I have a bachelor's degree in computer science and a master's degree in data science and artificial intelligence. And I've been working in the industry of large language models and building AI agents for the past 7 to 8 years. By learning the skills of building AI systems, large language models, and AI agents, I've landed multiple high-paying jobs, and I've also built a small freelancing career on Upwork, and I've made over $100,000 on it. And hopefully throughout this series of tutorials, practical tutorials, I'm gonna teach you how to build AI agents from scratch using the framework of LangGraph. And I'm gonna take you from the first steps of building an AI agent, like what does an AI agent even mean? So I'm gonna take you through all the steps from the very beginning of explaining the core concepts and building a practical prototype together to the final stage of actually building a deployable version in production and how to be able to use and deploy AI agent in your own projects. Hopefully it will also help you get high-paying career. So without further ado, let's start with the very first concept, which is like, what is an AI agent? I'll explain a little bit the differences between standard large language model and the AI agent. So let's start with the LLM. So the LLM, as the name stands for, is like a large language model. It's a large set of parameters or neurons that have been trained to produce a set of tokens or a sequence of words. An LLM, like a chatbot, like for example, a ChatGPT, responds with text, and it's also like a static conversation. Whatever you tell it, whatever you ask it, your input goes through the parameters or the neurons of the large language models, and it gets you back the answer based on the processing that happened inside these neurons, and there are no external actions. So if you just take an LLM or a model, large language model by itself, it doesn't have any access to the internet, doesn't have access to external actions. That's why when ChatGPT, for example, was introduced at the beginning in 2021, it was built on top of like GPT-3 large language model, and at that time they didn't have like the ability to search the internet. So you just ask it questions and it will answer you based on the knowledge of the model without reaching out to external resources or the internet, for example. On the contrary, an AI agent is actually built on top of an LLM. So you need an LLM to actually have an AI agent on top of it, and it uses tools. So it's not only the processing of the neurons of the LLMs, there are also external tools. So think of the LLM as your brain, and your brain when you're offline, completely offline. You do not have access to your phone, you do not have access to any tools, you do not have access to the internet or to Google. And if someone asks you a question or gave you a task, you will do it based on the processing of your neurons without actually, for example, searching the internet, because you don't have the tool to actually search the internet, for example. So the agent, on the contrary, is the brain, the LLM, in addition to other set of tools that we give to this LLM. So for example, we can give it internet search. So this is a tool that we can enable the LLM to access the internet, for example, in addition to the knowledge that is already embedded and stored in the parameters or the neurons of the LLM. It can also make decisions on how to solve this task and what tools to use in order to solve it. And then it takes actions based on these decisions. So it makes a decision to, for example, use the internet search tool, and then it's going to use that tool to search the internet and do the actual action. And then it will get back the results from the search, and then it will process these results and it will give you the final answer. And then it keeps looping until the answer is solved. So this is also, the looping is another aspect of an AI agent, because an LLM, like by its standard form, it will just give you the answer directly, what comes out of the parameters or the neurons, while with the AI agent, we can check for this answer and we can repeat, for example, the process. We can search the internet again. We can do multiple things in a loop until we get the answer that satisfies the user. So I think this comparison helps understanding the differences between the two concepts. And hopefully it makes the concept of an AI agent clearer to you. And this is actually, it's very simple, but the term has been used like a lot lately on the internet. And I think some people confuse the term and like don't know what it actually means. So it's at the beginning of our series, I think it is helpful to define this term. So second thing, to build an AI agent, we need some components. We need the main components of the AI agent. So for that, I'm going to be using a Python library, a package called LangGraph. So LangGraph built the building blocks of an AI agent. Then we can put together Lego pieces in order to build our AI agent. So the first thing is a graph. Let's make the analogy of a factory. So our AI agent is a factory. So the floor plan can be thought of as a graph. So kind of like the floor plan of the factory and where all the pieces go inside the factory, that can be the graph. A node in the graph, so the floor plan of the factory is the graph. A node in the graph is a worker that basically can do a specific task. For example, it's like when we're assembling cars, a node in the graph could be like the final point, for example, in the production where we put the paint and the final touches on the car. That could be a node or a worker in the graph. Edges can be thought of as the conveyor belt that actually moves parts or moves the cars between the states on the stages or the nodes or the workers of the factory. So for example, at the beginning, we have like the separate pieces of the car, and then we have the state. So we have the graph, which is the floor plan. We have the node, which is the worker or a step in the process. We have the edge, which moves the parts between the nodes, between the workers. And then we have a state. The state is the product that is moving through. So the state is actually the parts themselves or the pieces themselves that are being moved through the edges. These are the four components that we're going to be using. We have a graph, we have the nodes, we have the edges that connect the nodes, and then we have the state, which is carried out between the nodes in order to save the status of the work and to save what has been done so far and what needs to be done next. And now we have the tool use. So as I told you, a normal LLM doesn't have access to tools, while an AI agent have access to tools. So what tools we have, or like how a tool using agent actually looks like, or how does it work. So here's an example of a question that you might ask. So let's say, what is 234 times 567? If you ask that to a normal LLM, like ChatGPT, for example, GPT-3 or GPT-4, it might actually not be able to make the calculation by itself because, let's say, because your brain, for example, is not a calculator. If I give you like very huge numbers to multiply, you will not be able to, unless I give you the tool, which is the calculator, to be able to calculate the answer to that question. So then, so this is the query. This is the query stage. When we ask the question, then it goes through thinking, or it goes to our brain. Okay, we think of it. Then we say, okay, what is this? What is 234 times 567? Oh, I need to use a calculator, right? So I need to make a decision. So this is the reasoning step. So for example, in this case, we're going to be using like an LLM. Let's say it's Claude. It analyzes and decides, okay, I need to use the multiply tool, right? After it decides to use the multiplying tool, it's going to then take the action. It's going to take the calculator and it's going to actually put in the numbers in the calculator and the correct operation, which is like the multiply operation. So it's going to actually take the calculator and actually use it and put in the numbers and get out the result. This is how the AI agent that has access to a tool work. But if you have, let's say if you ask that to just an LLM, just like the brain, the neurons themselves, they do not have access to a calculator and they actually might hallucinate the answer, or they might tell you that, okay, it's very difficult to do it, and therefore they might not be able to. So this is a very simple use case, but of course in real life, you might have like more complicated use cases, like for example, booking flights or managing apartments, for example. This is actually all you need, the four core components, tools, how tools work. That's all. Now let's just go to like a live coding example. So I have two coding examples for you. The first one is a very simple agent using the core components without a tool. So first we need the graph, right? To construct a graph, we need the nodes. So in this case, we will have just a greeting node, just a simple node. A node in LangGraph is just a Python function that does some task, right? So in this case, the node or the worker will have the task of just saying hello, greeting. It's gonna just take the user message in this case, and it's gonna reply back with a greeting. So this is the very simple node. It's gonna take what message we sent to the AI agent, and it's just gonna send the same message like with a greeting. Okay, now how it will be able to get the user message? It will be able to get it through passing a state. In the same analogy of like the car factory, when you move pieces to the step of assembling the engine, for example, or installing the engine in the car, this worker that does this process, for example, a robot, it needs actually the raw material to do it, which in this case is the state. So in order for the greeting node to give us the greeting to say hello, or hello, you said this, nice to meet you, it needs actually to know what is this, or what is the user message that we're using. In this case, we pass the state to the node and we get back the response from this state. So this is the worker, this is the function, it's a normal function in Python. And the state is very simple, it's just one message that gets passed to the node. And now here we have how we will assemble the agent. So first of all, we need to define the state of the graph, going to be passed throughout the nodes of the graph. So now we add the node, which is the greeter node, and we give it a name, greeter. Then we need to add edges, right? So we add the edge from the start. So start is a special node in LangGraph that tells you how to initiate or start the production. You can think of it as the entry point to the graph. And we add an edge. So from the beginning to the greeting node. So when at the beginning we start, then we pass the greeting to the node. And then from the greeting, we return the answer to the user. So this is the end, which is the end product of the graph. So the graph looks something like this. It's a very simple graph. We start and then we greet based on the state, then we end. So now let's say we want to run it. So we create this, we run the function to create the agent, and then we invoke the agent with a message. So this is the input, this is the state input. So as we explained before, the greeting node needs to get the state as an input, right? Like it needs to know the user message to use it for the greeting. So that's when we invoke the graph, we will pass the message as the input. So now let's just run it and see how it works. So we can just like run it like this, simple Python, simple agent. So we passed hi there. So the agent response was hello, you said hi there, nice to meet you. We also run it again with a different input, which is like what's up. Hello, you said what's up, nice to meet you. So this is a very simple example of an agent that has the 4 components that we just explained. We have the node, which is the worker, in the greeter in our case. We have the edges that, and also like we have the start node and the end node. So we have 3 nodes in this case. Then we have the edges that pass the state between the nodes of the graph. And we have the state itself, which is in our case, is just a simple message, right? It's just a simple message, which is a string. And we have then the graph itself, which is the combination between nodes, edges, and state. Yeah, so that's actually it. That's all actually you need to know about an AI agent. Now let's run the little bit more complicated example, which we're going to be using a tool. So it's the same multiplication use case. So you have two numbers, and you want to enable the LLM to be able to perform multiplication processes and also return the result back to the user. So to have that, we need first to create the tool. So a tool is also similar to a node. It's just a function as well in Python. Just in LangGraph, you have multiple ways actually to create a node in LangGraph. One of them is to pass the tool decorator, which is just you have a normal function that has the function signature, name, and the arguments, and it also like returns a result. And you just decorate this function using the tool decorator. You don't actually need to know a lot about the tool decorator to be able to understand the concept. Just you can think of it as a function that does something as a tool. So in our case, for example, it's just a calculator that multiplies 2 numbers. So it takes the input, the first number and the second number, and then it returns the answer. So first number, second number, and then it returns the product of A and B, the first number and the second number. So this is the first step. We create a tool. Then we need to define the state. We just need the message again, but in this case, it's not only one message, it's actually a set of messages. So this time we use a special message field. The add message functions, let me explain what this means. So in most cases, actually, what you want your AI agent to do is not to just receive one message and like just manipulate it in some way or use some tool or like do something to the message and then put it in the output. Usually you want to have a conversation with the user. So that's actually the main idea of agents, is to maintain a conversation with the user while performing actions, using tools, taking decisions, etc. So to achieve that, we don't only just need one message like our previous example, but we need a list of messages. We need to save the user messages and the responses of the AI agent as well in a list of messages. Think of it as the list of messages in the conversation you're having with ChatGPT, right? So it's like a list of messages that you save in order to answer the new question. So it's like it provides context for answering the current question. So it tells LangGraph to update the state after every turn in the graph, after every message is added to the state. So whenever you pass a message to the state, it's going to be added to the graph, or like it's going to be added to the list of the messages. So if we go to the add message functions, we can see it's like it merges two lists of messages, updating existing message by ID. So actually, you don't also need to care a lot about it. We can go deeper in details, but all you need to know at this stage is that we need to save the history of messages, and the way we do that is we have a list, and also we annotate that list. We give it a function that enables us to add messages to this list. So whenever we pass a message in the state, it's gonna be appended to the list of existing messages in the state as well. So don't worry about it. It's just think of it as a list of messages. So first we need the tool, right? In our case, it's the multiplication tool, the calculator, and then we need the list of messages to maintain a conversation. So, and this will be the state. Okay, so now after we have the tool, after we have the state, now what we need the node. The node in our case will be the decision-making node, the same as we had in our example here, right? So the thinking node. So now we have the multiplication tool. Now we also have the state that maintains the list of messages that we exchange with the AI agent. And now we need the thinking node, right? We're gonna call it just an LLM node. It's also like a terminology or like a naming convention that is used inside LangGraph. There's an LLM node. So an LLM node just takes the state, similar to the previous agent as well. And now we're gonna use an LLM. It's gonna be the thinking brain. In this case, it's Claude Sonnet 4.5. Then we need to pass the tool to the LLM. So we need to tell the LLM that you are given this node and you are able to make a decision to use this node. So for this, we have a function in LangGraph called bind tools that enables you to connect an LLM with a tool or a set of tools. Not only one tool, but you can provide a list of tools. In this case, we provide our multiply tool to the agent or to the LLM node. And then it returns a response. So first, it takes the list of messages, it takes the conversation, and it has the option. It has the option to use the tool. It might not use it. As we see here, it might just return the answer. For example, if you just say, "Hi, how are you?" Probably there is no need to use the multiplication tool in that case. But if we asked the AI agent, "What is 2 times 4?" Maybe it's a good idea to use the multiplication tool in that case. And the response is going to be LLM with tools invoke. So we're going to invoke that node or the LLM using the state as an input. So we're going to take the state messages as an input. So messages is a key in the dictionary of the state where we pass the messages from the state, right? So the state is the dictionary. In this case, it has only one field, which is the messages. So we need to pass it to the LLM in order to be able to answer or respond to the user query. Then we return the response in the messages field. So step 4, now we need to create a router. It's just to tell us that whether we need to return an answer or we need to actually execute the tool based on the LLM response. So now we have the should continue function, whether we actually should continue in the loop of using the tool or we should return the response to the user. How do we do that? We look at the state. So we look at the last message. So if the last message that we just returned has a tool called attribute, so whenever the LLM executes the tool, the multiplication tool, it's going to return a response, and this response is going to have attribute or the information, the metadata that the tool has been called. So we check that, we see whether the last message has the tool calls field in it and last message dot tool calls. So this is just to confirm that the LLM wants to use the tool. So for example, it's after this thinking point, we check, okay, does the LLM response has the metadata for using a tool, which meaning that the LLM wants to execute the calculator tool, or it doesn't have like a tool metadata, and therefore we can just return to the user. So if it has the tools metadata, the tool call, we return the word tools, otherwise we return the word end. So this actually, it returns just the literal, which is just the string tools or end, and I will show you exactly where we need this function. So now we actually create the graph. So first we define the state, as we've done in the first example. Then we add the LLM node, which is the main building block, this node, so we add this node. Then we add also another node, which is the tool node, right? So we add the tool node. So a tool node, it's actually a class in LangGraph that's gonna handle all the things related to the tool calling. After we define the nodes, we define the state, we define the nodes, then we define the edges. First, we need the start node. So we need to go from the start node to the LLM node, right? So we need like to define this edge. Then we need this edge, right? Which is a conditional edge. You see like the dashed edge, dashed one, it means it's a conditional one. So either we take an action to execute a tool, or we just finish the execution. So how do we decide that? We just use the add conditional edge function that we just explained. Sorry, the should continue function. So that I just explained. So if the LLM wants to use the tool, we just direct it to the LLM node. Otherwise, we just return back the result to the user. So yeah, so it should continue. So we start this conditional edge from the thinking node, right? We started from here. And then we use this function to decide. So we use the should continue function to decide whether we need to go here or here based on the output of the LLM. And then we need to give it the actual nodes, final nodes on the edges, right? So the first one is tools, the second one is end, and these names here, they should be exactly matching the literals and the strings that we defined in the conditional in the should continue function. So now we have the conditional edges, we have the first edge, we have the conditional edges, we have the thinking node. Now we need this edge, I think. That's the last edge that is remaining, which is the observation. So we add an edge between the tools and the LLM, and this is why we need this. We need this because we need to return the result back to the LLM to respond to the user query. Then we compile the graph, and now here we can run our example. So let me just run this code. So what do? We define we create the agent. We create the graph. We define the agent. Then we have multiple tests. So the first one is just a greeting, right? Hello, what can you help me with? So in this case, what we should expect is that the agent shouldn't decide to go to the calculator node. Instead, it should just respond, right? Yeah. And then the second test case will be what is 234 times 567, and then the last case is another one, just different numbers. So let's see the results. So calculator agent simple greeting. So for simple greeting now, where it's doing. So the simple greeting, the input was hello, what can I help you with, and the output was hello, I'm here to help you with various tasks. I have access to multiply function. So I can help you with multiplication. However, I can also assist you with many other things, etc. That's based on the LLM that we're using, which is Claude 4.5, Sonnet 4.5. So as we expected, the LLM did not go to the tool, and it just gave us the final answer, right? LLM has the final answer. Now, in this case, math question should use the multiply tool. So the query for this case is what is 235 times 567? And in this case, it should think, and it should take us to the tool, to the calculation tool. So let's see. Okay, so LLM wants to use the tool called multiply. This is the result, and we can verify it. I think it's correct, right? I have it here as well. And LLM has, and after that, after it returned the answer, the LLM decided to give us the final answer. So the LLM has final answer. So here's the final answer, which is also a string. So 235 times 567 equals to this number. So this is how it worked. It worked as we expected. First, it went here. It returned the answer. Then it thought again, and it decided to not use the tool again, right? Because it has the option to use the tool again, but it decided to just give us the final answer because that's what we just want. So yeah, another calculation. This 12.5 times 8, which is 100. That's correct. It's 100. And 12.5 multiplied by 8 equals 100. So in the first step, the LLM wants to use a tool called multiply, and give us this result, 100. And then the LLM has the final answer, and it gives us the final answer. So, okay, so notice how the agent works. Here are some instructions. So I'm gonna push this code actually to GitHub, and I'm gonna be pushing all the episodes to GitHub, because this is actually the first use case of an LLM, just like a simple LLM with tool using the loop, and basically it's like the simplest use case of LangGraph, like AI agents. And so thank you so much if you're still watching. I really appreciate it. I hope you learned from this simple introduction of AI agents. We have learned what an AI agent means, what it actually means, because on the internet a lot of people actually using this term for things that are not AI agents, and it's like it's annoying. So hopefully now you know what actually an AI agent means. Then you know what are the main components that make an AI agent that we need to use in order to have an AI agent, which is like a graph, node, edges, and state. Hopefully you have seen it in practice what all these components mean. And eventually we have built an agent, a full agent with tool. It's called React agent, because it is like a reasoning and acting agent. So it reasons, first it thinks, then it acts on the thoughts. So it can make decisions, it can decide to use a tool, or it can decide to just finish the conversation. So this is the very beginning. Thank you so much again for watching. And in the next episode, we will expand the use case and define more concepts that we need in order to build AI agents that are useful in real world applications. Thanks so much again for watching. See you in the next one. Bye-bye.